ready for oxidation and reduction. We're on the home stretch here then. Oxidation and reduction. I want you knowing all three of these definitions. All right, so let's look at these definitions. Oxidation and reduction. Your life is made easier if you know all three definitions because you can apply whichever definition is easiest. So oxidation, the original definition was you gained oxygen. And then a reduction would be losing oxygen, reducing the amount of oxygen. Now the problem with this is some reactions, it's difficult to tell how much oxygen you gained or lost. And so if I had, for instance, let's do C2H6, and I took this and formed C2H4, it's hard to tell if this was an oxidation or a reduction. Well, looking over here, how many things are oxygen? 0. And how many things over here are oxygen? 0. But this one has more things. We started off with more things that aren't oxygen. Now we have less things that aren't oxygen. So the percentage of oxygen went up. And so we oxidized. Ah, terrible, terrible. And so they quickly realized they needed another definition. And so another definition then here would be about the hydrogens. So an oxidation is when you lose hydrogens, and you lose them in sets of 2. And a reduction then will be when you gain hydrogen. And so if you gain hydrogen, then you're also losing oxygen because the percentage of oxygen goes down. It even helps us by having 2 definitions, helps cover cases where we didn't even have any oxygen. All right. Now, what this really came down to was electrons. And so it gave us a way of looking at these without really having any oxygen or hydrogen. So oxidation would be when we lose electrons. There's our symbol for electrons. And reduction is when we gain electrons. And so electrons follow the hydrogens. Whatever the hydrogen is doing, that's what that's going to be doing. All right. Now, when I was a student, I learned this with oil rig. All right. And so it was real common for I'd take my test, I write my name, I write PV equals nRT. I maybe wrote M over dB for my density, and then I'd slap out oil rig every test. Just as I got used to writing that, it became part of my name. Worked great in chemistry tests, not so good on my history exams. They always looked at me a little funny. All right, so oil rig, oxidation is gaining. Click down here on this. Oxidation, is losing electrons. Oxidation is losing electrons. Reduction is gaining electrons. And so this is a way to keep up with our electrons. All right. Now, the problem comes in the charges. And so when I look at charges, it causes us problems. Remember, if you have a positive charge, you have lost electrons. And so if you become more negative, you are gaining electrons. Okay? So the way I'm going to look at it is I'm going to look at this charge. So things that are neutral at 0, there's +1, and +2, and +3, and then -1, -2, and so on. -3 down here. All right. And I'm going to think of an elevator. So 0 is my ground floor. Now, if I am losing electrons, I'll be moving up. All right. So I'm losing electrons. I'll be going up, and that's oxidation. Now, if I gain electrons, that's reduction. So In oxidation, you go up. Reduction, you go down. Um, and so the way I always kept up with it, reduction, you reduce your height or your altitude. All right, you go down, you reduce, and then elevator. It doesn't matter if you're at the ground floor and you go down to -3, or if you were at +3 and you went down to the ground floor to 0. So reduction, you're going down. Oxidation, you're going up. This made it click for me in terms of the charges a lot more. All right. Um, it's really a matter of matching the definition to the problem.